Welcome students. Again, this is Ravi Shankar, and in this video we are going to study about the electrical field due to an electrical dipole. We have studied about the electrical field at a point due to a point charge. Now we are going to calculate the electrical field at a point due to an electrical dipole. But when we are considering the dipole, we are having two charges joined with the line called to be axial line. So I can consider the point along the axial line or along an equatorial line. Here I am going to consider a point along the axial line, and at that point what is the electrical field we are going to calculate. So an important question, and this question carries 5 marks. So let us see. If you are having a notebook, take your notebook and work this question along with me. When I am completing this question, you can able to learn this. Come on, take your notebook and first of all draw the diagram. Let us consider 2 points. One of the point as A and another point as B. At the point A, I am placing a charge minus Q, and at point B, the other charge plus Q is placed. When these 2 points or when these 2 charges are separated by a distance 2A, then this arrangement constitutes an electric dipole. Let us take a point at the center O called to be the origin. In your book that was being given as C instead of O. Okay, let us consider it as C. You take this axial line to get extended. On that axial line you consider a point, and let us take that point as P. I think in your book it is this point they have taken it as C, and this point they have taken it as O. Okay, let the origin, let us take it as O, and the point along the axial line I have taken it as C. From the center point, the point C is at a distance of R. Now I have to calculate, my task is to calculate electrical field at this point C. What is the total or what is the net electrical field at this point C? We have to calculate. Let us see how we can calculate. You see, if this distance minus Q to plus Q, that is A to B is 2A means, then this distance AO or OA is considered to be A, and this distance OB is also considered to be A. Now, what is the net electrical field at this point C means? We can consider 2 electrical fields at this point. One of the electrical field is due to this negative charge, and another electrical field is due to this positive charge. So, let us take the electrical field at this point C due to the negative charge as E1. So, at this point C, 2 electrical fields are acting. One is due to the negative charge and another one due to the positive charge. If it is due to the negative charge, let us take the electrical field as E1. If it is E1, it is acting towards the charge because it is due to negative charge. At the same time, the point C is experiencing another electrical field due to plus Q. Let us consider that as E2. That electrical field due to positive charge will act away from that of the charge. So it is acting away. First of all, let us calculate or write these 2 electrical fields. So first I am writing the electrical field at C. Therefore, I am writing the electric field at C, electric field at C due to the negative charge minus Q kept at A is equal to E1, or I can write it out as E1 vector. What is this E1 vector? I can get the value. So E1 vector is equal to, we have calculated according to a point charge, 1 divided by 4 pi epsilon 0 magnitude of the charge divided by square of the distance. What distance? Minus Q to the point C, that is from A to C. So if it is due to minus Q, then I am stating it as E1. I have taken it as E1, but in your book they have taken it as E minus vector. So I can write here also, I am writing it as E minus vector. Then Q divided by, from where I have to write, from A to C. So I have write the distance as AC square into, along what direction it is acting? It is acting towards the charge. So from C to A it is acting. So I am writing it as along CA. Now let us simplify this. So E minus vector is equal to, I can write this 1 divided by 4 pi epsilon 0 into Q divided by, what is this AC square? Look at the diagram. See, AC can be written as AB plus BC. AB is 2A and BC is considered to be what? Or I can take like this. OC is considered to be R and OA is considered to be A. That is, AC can be written as OA or AO plus OC. AO is A and OC is R. So AC can be written as R plus A, the whole square. Along what direction? It is towards the charge, negative x-axis. Since it is in the negative x-axis, we can say it out as minus I. Minus I means we can say that it is minus of the dipole moment, because dipole moment vector always acting from minus Q to plus Q. Here the direction is from plus Q to minus Q. So I am writing it as minus P vector. This can be written as E minus vector is equal to, take that negative sign in front, so minus of 1 divided by 4 pi epsilon 0 into Q divided by R plus A, the whole square, multiplied it with P vector, or I can say that P cap, because I have taken the negative sign prior. Take this as equation number 1. Similarly, you write the electrical field at C due to plus Q. So here I am writing the electric field, okay, the electrical field at C due to plus Q. I am writing it as E plus vector. In diagram, I have written it as E2. Here I can consider this E2 can be written as E plus and E1 can be written as E minus. So what is the value of E plus then? E plus vector is equal to, again, 1 divided by, similar case as that of the previous one, 1 by 4 pi epsilon 0, Q divided by, plus Q is at B and the point C. What is this BC? BC can be written as OC minus OB. So from R I can subtract the value of A. I can write this as R minus A, the whole square. Along what direction? Along, see, it is acting. Positive charge means electrical field will act away. So it is acting along BC. That is negative charge to positive charge. How I can simplify this? E plus vector is equal to, again, 1 by 4 pi epsilon 0 into q divided by r minus a the whole square multiplied it with, I can write it out as p vector. So because it is acting along BZ is minus q2 plus q. So I can say it again as E plus vector is equal to 1 divided by 4 pi epsilon 0 into q divided by r minus a the whole square, either p vector or I can write it out as p cap. Take this as equation number 2. Now see, at C we are having two electrical fields, one due to the negative charge and another one due to the positive charge. See, compare equation 1 and 2. Comparing equation 1 and 2, we can say E vector minus or E minus vector is greater than that of, sorry, not E plus vector is greater than that of E minus vector. Why? See, E plus or E minus is decided by the distance. Here it is r minus a the whole square, here it is r plus a the whole square. R minus a is inversely proportional to electrical field. Our distance square is inversely proportional to electrical field. So lesser the distance, greater the magnitude. So I have written it here. E plus vector is considered to be greater than that of E minus vector. Now, how to calculate the total electrical field at C? Because two electrical fields are acting at point C, what is the net electrical field? Or what is the total electrical field? Therefore, we can state like this: total electric field at the point C can be got using superposition principle. Let us see how we can able to get the reading. See how you can able to get the resultant. So see, total electrical field at C can be got using the superposition principle. What is superposition principle? So I am writing here according to superposition principle. According to superposition principle, we can state E total vector is equal to E plus vector plus E minus vector. How we can get? So we can write adding equations 1 and 2. Adding equations 1 and 2, we get, what are the two equations? So I can write E net or E total vector is equal to, what is this E plus? E plus is, or I can state E minus. What are the thing? E plus I am writing first of all 1 divided by 4 pi epsilon 0 q divided by r minus a the whole square into p cap plus r plus E minus. What is E minus? E minus is minus of 1 by 4 pi epsilon 0 q divided by r plus a the whole square into p cap. Now simplifying, how I can get the answer? See, E total vector is equal to 1 divided by 4 pi epsilon 0 q divided by r minus a the whole square p cap plus, here you are having minus, so minus of again 1 by 4 pi epsilon 0 q divided by r plus a the whole square into p cap. Now simplify. How we can simplify? We can simplify by taking the common factors. See, ordinary mathematical simplification, let us calculate it or simplify it. You see, E total is equal to, again, E total vector is equal to 1 by 4 pi epsilon 0 is common. So I have taken 1 by 4 pi epsilon 0. Q can also be taken out. So remaining 1 by r minus a the whole square minus 1 divided by r plus a the whole square, and again here also p vector, here also p vector or p cap, that too can be taken out. Now simplify the terms that is available inside the bracket, that is equal to, you can state 1 divided by 4 pi epsilon 0 into q into, take LCM. Here it is r minus a the whole square, here it is r plus a the whole square. So we have to multiply, or a minus b into a plus b, a square minus b square. So I can write r square minus a square, then you are having another square, so whole square. So what is the numerator value? Here r minus a, so I can get r plus a the whole square minus, here I am getting r plus a, so r minus a the whole square, multiplied it with what? Multiplied it with p cap. So again we have to simplify this, mathematical simplification. How we can simplify? So again I am writing E total is equal to, see, 1 divided by 4 pi epsilon 0 into q. Denominator I am writing as it is, that is r square minus a square the whole square. If you want to do the simplification, I can do. This can be expanded using a plus b the whole square. So I can write it out as r square plus a square plus 2ra minus, again a minus b the whole square multiplied with 1 minus. So I can write r square plus a square minus 2ab multiplied with minus. So I will be getting minus r square minus a square minus of minus plus 2ra multiplied with what? Multiplied it with p cap. Clear? Now on simplification, this r square and this r square, this a square, this a square will get cancelled. So we get the answer as 1 divided by 4 pi epsilon 0 into q into 2ra plus 2ra. I can get the answer as 4ra divided by r square minus a square the whole square into p cap. So this is what we can state, that E total electrical field at point C given in both magnitude and direction. So we can state like this. This equation gives the total electric field at C due to an electric dipole given both in magnitude and direction. See, but at the same time you can consider a special case. What is a special case? See, if you are taking the point C, if, let us put it like this, special case, but including in that same question, if the point C on the axial line, point C on the axial line is far away from the dipole, is far away from O, what will happen? If it is far away from O, what will happen? then R will be very greater than that of the semi-length A. Then what will happen? Then we can state that then this R is very greater than that of A. So what I can do, R square minus A square the whole square is nearly equal to R power 4 neglecting A. An approximation is being applied. Okay, then when you are considering the point C is very away or far away from O, then we can state that R is very greater than that of A, or R square is more greater than that of A square. So in this expression, R square minus A square, R square minus A square whole square, which is nearly equal to R power 4 neglecting this value A square. Therefore, we can get E total vector is equal to, what is the formula? They have written 1 divided by 4 pi epsilon 0 Q into what we have written in the previous case. You can see here. If you are writing it, you can see it in your notebook. See, Q into 4RA divided by, instead of this R square minus A square, I will be getting R power 4 multiplied it with what? Multiplied it with P cap. Now I am going to simplify this and get the answer. What is that simplification? See, what is that simplification? Here you can cancel one R. Instead of R power 4, you can get R cube then. So we can state E total vector is equal to 1 divided by 4 pi epsilon 0 into Q multiplied with, how I can write this 4a? I can write this 4a as 2a into 2 divided by R cube multiplied it with P cap. So 1 divided by 4 pi epsilon 0, rewriting this as 2 into 2qa divided by R cube multiplied it with what? Multiplied it with P cap. What is the value then? I can write like this: 1 divided by 4 pi epsilon 0. Okay, 1 divided by 4 pi epsilon 0. 2 into, what is 2qa? 2qa is nothing but the dipole moment P. So this, instead of this 2qa, I have replaced that with what? Replaced with the dipole moment P divided by R cube multiplied it with P cap. This is considered to be the net or the total electrical field due to an electric dipole at a point on the axial line, given both in magnitude and direction. Now we can state the direction. What is the direction? See, P cap, it is in positive symbol, means it is acting from negative charge to positive charge. So we can say the direction of the electrical field is, the direction of the electrical field is in the same direction, as that of dipole moment, as that of dipole moment, we can state. Okay, as that of dipole moment. Clear? Are you able to understand? This is what we are calling it out as an expression for electrical field at a point due to an electrical dipole along the axial line. By considering a point along the axial line, we have taken two electrical fields at that point Z, and by applying the superposition principle, we have calculated the electrical field at the point along the axial line of an electrical dipole. Very important question. Go through it, write it again and again, and it will be easily understood. Thank you. All the best. Let us see in the next video.